Hello, my name is Julie Robb with Ida Culverhouse Broadview, one of Air Living's 8 premier retirement communities. Before we start today's presentation, I would like to share a little bit about Air Living and the Air Living Memory Care Program. Air Living is a local family-owned collection of 8 communities featuring spacious, elegant apartments, exquisite cuisine, and robust, meaningful life enrichment activities to keep our residents engaged, entertained, and connected. Additionally, our tranquil and well-maintained outdoor gardens and courtyards are perfect for visiting with friends and family or just enjoying the beauty of nature. All of our communities offer independent living as well as assisted living options. Air Living Memory Care is offered in our terrace neighborhoods at Ida Culverhouse Broadview and the Gardens at Town Square. Both communities utilize the best friends approach to providing care, which is based on the notion that what a person with dementia needs most of all is a best friend who empathizes with their situation, remains loving and positive, and is dedicated to helping the person feel safe, secure, and valued. To learn more about Air Living Communities and the Air Living Memory Care Program, I encourage you to visit our website at www.airliving.com. Or you can call us at 206-470-8036 to ask questions or schedule a tour with the community you are most interested in. All right, now on to our main event. We are honored to host Dr. Charles Burnick, who will be presenting on how aging affects brain function and thinking. Dr. Bernick is a neurologist and clinical professor who has been involved in care and research in the field of Alzheimer's disease for over 30 years. After serving as associate director at the Cleveland Clinic, he joined the Memory and Brain Wellness Center at the University of Washington and leads their clinical trial groups. So with that, I'm going to turn it over to Dr. Bernick. Dr. Bernick, do you have slides that you would like to share for the presentation?
I sure do.
Okay, I'm going to stop sharing and you can go ahead and pull those up.
Okay, let me share my screen with you guys. Okay, so let's share screen. Wait, host disabled participant. It says host disabled participant screen sharing. I mean, you may need to enable it.
Julie, do you want to make Dr. Bernick a co-host, please?
Yes, give me just 1 second here. We're just looking for your name on the list. There's so many people at this webinar.
Yeah, sorry about that. Yeah.
That's okay. Let's see.
Julie?
Yes.
It's under Jesse Maupin. It's, I think, the third one down.
Yeah, you're right. It's sorry about that.
That's okay. One second. Okay, I think that's it.
Very good. Okay, yeah, good. All right, perfect. Thank you. So now let me pull up share screen. Okay. So can you all see, is the slides up now?
Yes, that looks great.
Okay, perfect. Okay, great. All right. Well, first, thank you very much for inviting me to present today. It's one of my favorite topics, which I call the power of positive aging. We always try to frame things in a positive manner, but I think there is a lot positive about this, and hopefully I'll convey that to you. Although I will say this, most people have just the opposite impression. That is, you know, as you get older, you're just going to lose it, as far as whether it's cognitive function or physical function. And I pulled out this old historic cartoon, which dates back a long way. It's actually the world's first senior moment. where we see back that he says, oh crap, was that today? And there is some truth to that. I mean, as we'll see that over time, I mean, things do change as you get older, but it may not be as dire as we think. So I'm going to start by a little quiz. I'm not going to ask you all to answer online, but just to think about these things, and hopefully we'll cover this as we go on. So first, the question is, loss of memory is a normal part of aging, so that you can answer yes or no. Second question, the brain can form new connections throughout life. Again, yes or no. And then the third is, we can predict which individuals with memory complaints will progress to Alzheimer's disease, dementia. That is, do we have the ability now to actually tell you all if you're going to develop Alzheimer's disease? Well, if you have it, are going to develop it. So that's a yes or no answer as well. All right, well, let's get on our journey and see what we can, if we can answer these things. So just to put it in context, the population over 65 is just going to increase, 20% of the population by the end of this decade, and it's going to continue to go up. And that's because people are living longer. So if you make it to 65, on average, just on average, you have about 20 more years. And you know, it's not unusual, of course, for people living into their 90s and in healthy, I mean, having a healthy life into their 90s. What's really interesting is that given the risk factors for Alzheimer's disease, which we'll talk about, if we could just make a little dent in these things, just reduce these risk factors by a small amount, 10 to 25%, we could reduce by 500,000 people the number of folks who develop Alzheimer's disease, at least overtly, the dementia, which we'll talk about. So there is a value to get on top of this as soon as possible. Now, first question, is memory loss a normal part of aging? Well, we actually know a fair amount about this, but there are some nuances. So when we talk about memory, without getting too technical, there's actually several different types of memory. So you don't have to remember these, but there's what we call episodic memory. So that's what we usually think about. That is your ability to remember events, details of events, conversations, things like that. There's something we call working memory, and that's your ability to take information you know and manipulate it, to use information you know and either make decisions based on it and so on. Then there's something called semantic memory, which is your knowledge of things, knowledge of facts, knowledge of words, meaning of words, things like that. And then there's procedural memory, and that's your ability to remember how to do things, to skills that you've developed over time. It may be shaving for a man, it may be dressing or cooking or things like that. So, and what's interesting is you don't lose these all together. In other words, they can run independently. Some people have more problems with episodic memory. Some conditions affect semantic memory more. So I just bring this up because when you talk about memory, it's not just one thing. And just to go through how we remember things in general, of course, we're bombarded with information. I mean, as you go on today, things going on around you, the temperature and other people talking and various other things. So we're bombarded with information. We can't remember all this. So what we have to do initially is encode, that is, put it actually into your brain, into this short memory bank that we have. And then from there, if we really want to remember it, we have to kind of put it back into another bank, which is your longer term memory. And then even if it's in there, you have to be able to retrieve it. So again, it's just the fact that there are multiple steps to it, and various conditions can affect different areas of this process. All right, so what's normal and what's not? So it is true, you know, as you get older, things decline, but not a lot. And certain things decline more than other things. So if we just look at, this is just a kind of a cartoon of what happens, you know, as you get older, things kind of change a little bit. If we drill down on this to see kind of, well, what are those things that change? So the things that change normally with aging, probably the fundamental thing is just your slowing of processing information. So things stay on the tip of the tongue a little longer. It just takes a little longer to come up, to work through problems, to do. So that is normal as you get older. So that's expected. There actually are mild changes in memory. So for example, if you're given a list of words to remember, you won't, generally when you're 80, you won't be able to remember quite as many of them as somebody who's 20. But what's interesting, those that you can immediately, that you could encode, that you could put in, you usually can retain. So there are mild changes in memory, but they're not dramatic. And I think the other big thing is that generally other cognitive abilities are preserved. Now, if we think about comparing people, I'm just going to show you different kind of areas that we test for. So for example, if the green bars are somebody who's 50 years old, the yellow bars are on average somebody who's 80, and these are normal people. And the blue dotted line is what the performance you'd expect from a 20-year-old. So actually, certain things, get better as you get older. Like your vocabulary increases over your lifetime, and at least when you're 80, it's not any worse than when you were 20. Mental math, it's about the same as when you're 20. You're still able to do it. Verbal fluency, which is being able to produce language and words, that's not that much changed. So those things are relatively preserved. However, there are some things that aren't as preserved. One is this idea of selective attention. That's being able to shift from one thing to another, your ability to shift quickly. Again, this is probably a processing thing. Same thing with mental flexibility. And so these things, again, the processing speed and how fast you can work through things do decline over time. But I think I do want to emphasize the things that are relatively preserved. So one is what we call your crystallized knowledge, and it's a great term, the crystallized intelligence. What it really means is your wisdom. So the things that you've learned over your lifetime, normally in a normal, without any other pathology, that stays. So you don't really lose your wisdom. And you can see long-term memories stay kind of put for a pretty long time. Procedural memory, that's again the ability to carry out tasks, to do things that you've learned or developed over your childhood and development. We talked about verbal fluency and working memory. There may be some changes. That's kind of debatable. But there are some changes that can occur. So as we said, there's minor changes in short-term memory that is learning new information. Processing speed, I think, is the big thing. And so on. So to answer this question about, is memory changes part of aging? Yes, to some degree, but not to a great degree. And it's more just a slowing of working through problems and things like that, that you're going to see the most. Now, it's also important to remember that a lot of things, aside from brain diseases, can affect your memory and memory performance. So depression, for sure, or anxiety or stress, all can worsen your ability to recall information. This is probably due to an encoding problem. That is, you're just, because depression and stuff, your attention or focus is interfered with you, and you can't really put in those memories. Sleep deprivation, for sure. This is why sleep apnea is a common thing we look for in people who have memory disorders or other sleep problems. Medications is a big offender, and even some medications that you take over the counter, for example, Benadryl, can interfere with memory. Sleep medicines, in fact, almost all the sleep medicines, except for some, potentially could affect memory. Narcotics, for pain, anticholinergics that are often in medications for bladder function and so on. So we know there's a lot of medications that can interfere with your normal memory function. Certainly medical conditions that are not treated, vitamin deficiencies, thyroid problems, and then alcohol. Is another big one. Big in the sense that it is related to the amount that you drink. So if you have a glass of wine a night, no big deal, probably. But if it's now getting to be 3 or more, then that becomes certainly an issue or a problem that can affect memory. So it's just important to remember that if somebody's noticing memory problems, it doesn't immediately mean that they have a brain disease. It can be tied to one of these other things. Now, I will talk a little bit about kind of what happens with aging actually in the brain itself. So one question comes up is, do we just constantly lose brain cells? I mean, is it that we just start out with billions and billions of them and then they start kind of going away as you get older? And you do, but again, it's actually not an overwhelming loss. So people's brains shrink over time, but it's really not significant. So let's say you start out at 20 with 20 billion cells. By 90, you might have about 10% less. I mean, that's not insignificant. I mean, that's still 2 billion, but I mean, relatively, it's not a huge amount. So we do lose cells over time, just from aging, but it's not an extraordinary amount unless you have a brain disease. Then there's these so cells in the brain are connected, and they're connected through what are called synapses, which are really what allows cells to communicate. They're the connections between the cells. And there is some age-related loss of these connections, and some of this probably for good reason. That happens even in early development. We start pruning and getting rid of excess connections that aren't needed and that are just almost a detriment. Same things happens to some degree with aging. So there are some loss of these connections over time. And then there's some positive things that happen as you get older too. So some of these connections can reform. This is what in the cartoon, we see the sprouting. That is, you're seeing this regeneration of some of the connections between the cells. So it's not just a zero-sum game. I mean, that everything just gets worse and there's nothing that changes. The brain is very plastic. You can renew connections throughout your life. So that's what brings up this whole idea of neuroplasticity. And what we use that fancy term for is just that it's the various processes in the brain that either help maintain the structure of the brain or can compensate for age or disease-related changes. And so this neuroplasticity, there's several mechanisms we have for that. So one is you do have stem cells in the brain. So that is, you can produce new cells. Now, there are not a lot of them, but there are stem cells actually still in the brain. There's this concept I just mentioned, which is the synaptogenesis, that is developing new connections between cells, or improving the branching and having more reserve. So these are all things that can occur, are biological measures that we know happen in the brain throughout life, and that we want to really try to leverage. To go a little deeper into it, the memory of the brain is thought to be the hippocampus, and we know that there are stem cells in the hippocampus, and under appropriate conditions, you can stimulate the stem cells. So things like exercise, aerobic exercise, is known to stimulate stem cells. There is other medications that can prompt stem cell growth, but we know that those stem cells can be triggered and developed. Again, we know that there's ways that we can remodel the nerve itself, the brain cell. In this picture, the drawing that's listed as A. So that's actually what a brain cell or neuron looks like. So there's a little bulb at the end of it. That's where the cell body is. And then you have all these branches that go to other cells, that connect it to other cells. So with aging, you could follow one or two pathways. So you could either follow bottom pathway, that is D&E, which is you start losing more and more of these branches or connections. It's like a tree branch just kind of dying back or rotting away. Or you can have a tree that actually kind of grows and arborizes, and like if you fertilize it, and the fertilizer that again we know may be helpful is exercise, staying mentally engaged, and maybe substances and things that we do through diet, and so on. So this brings up, I kind of touched on this already, but what are the strategies that we all could do to leverage neuroplasticity? So exercise, by the way, has really the most information about it as far as stimulating stem cells and this branching of these cells. People often ask, well, what's exercise? I mean, what do you consider exercise? Is that working in the yard? Is it walking your dog? Is it, what is exercise? And we only can go on models that are done, or studies that are done with basically with animals initially, and try to translate that. But it seems like aerobic exercise is the most potent factor. Aerobic exercise meaning something, to get your heart rate up a little bit for a sustained period, which is often thought to be about 30 minutes, give or take. So that's usual recommendation, at least 5 days a week of some activity, brisk walking, exercise, bike, swimming, whatever you want to do that get your heart rate up for that period of time. We think diet's important. I'll talk a little bit more about this specifically, but really a diet that's rich in antioxidants, and that's the Mediterranean diet is the one that people talk about the most. And the Mediterranean diet, because it has foods, green leafy vegetables and berries of all type, dried fruit, things like that have a lot of antioxidant properties in it. And so that's kind of the typical example of an antioxidant diet. There's spin-offs of it. One's called the MIND, M-I-N-D diet, the DASH diet, which is kind of for the heart. But I mean, it's the same kind of concept. We think cognitive engagement is important. So mental exercise, that can be from very structured things like these computer programs, Lumosity, stuff like that, to really more informal things, learning a new language, or learning to play a new instrument, or or reading new books, or things where you have to challenge yourself, and often usually it's a variety of things that probably do the most. And stress reduction is really important, just as I mentioned before. Stress is a potent factor to interfere with memory function, and so stress reduction, mindfulness can play a role actually in helping brain plasticity. And then there are potentially pharmacologic measures. Now, I'm just going to mention a couple of things about the supplements and things like that you might read about, because a lot of things have been talked about as maybe being beneficial. So I'll start with curcumin. That's derived from turmeric, which is the root you see there. So it's, as many of you know, it's used as a food preservative and a spice. What got people interested in this is that it was found that in India, the incidence of, or the prevalence of Alzheimer's disease is 4 times less than it is in the US and many developed countries. So people said, well, why is that? Is it a genetic thing? Is it maybe something in their diet? Turns out curcumin does have a variety of effects that could be beneficial for the brain. So it is an antioxidant. It's an anti-inflammatory, or can act as an anti-inflammatory. It also may block one of the proteins that's involved in Alzheimer's disease, which is called amyloid, and which we'll talk about later. So there's a lot of things that, make, that might have some benefit. The problem with it is truly it's hard to absorb. So turmeric is hard for you to absorb. It also, by the way, even curcumin has many chemicals in it. So it's not just this one chemical. And the big problem for us on our end is that, and what makes it hard to recommend it or recommend how much you should use of it, is that there are no human trials to show any benefit at the moment. So I'm not saying there's anything bad about it. It's just that from our perspective, it's just hard to advise a person on, whether to add curcumin in and how much to take and so on and so forth. Resveratrol is another interesting substance. So it's found in grapes, red wine, berries. Now it's kind of interesting. This is like a lot of things in science that you guys probably have encountered, which is, there's older studies suggesting that, having a glass of wine is, reduces your risk of Alzheimer's disease and so on. So that was around for a long time. So now there's more recent suggestion that any alcohol reduces actually increases your risk of having cognitive impairment. So, what's a mother to do? But resveratrol, there's a lot of things that are potentially interesting about this substance, is because it has protective properties, again, in models and in laboratory models. However, the problem is you have to get enough resveratrol into the brain to have these protective properties. You have to drink a case of wine a day. Now, if you got it from wine, now that would be a lot of fun, but it also probably is not practical. So people have made resveratrol, in supplements, and it was tested actually in Alzheimer's disease. And unfortunately, the trial did not show a benefit, but it may be because it was tried in people who were too far along in the disease. So again, we don't know about resveratrol. I mean, don't have any strong evidence that it works. We don't know what the right dose is, but it probably warrants, more looking into perhaps earlier in the person's life. I mean, not drinking cases of wine, that is. How about ginkgo? This is one, you hear a lot about ginkgo. So it's, found in trees that are in the East, so Korea, Japan, China. Now the ginkgo tree can live a long time, 1,000 years. So you'd think, boy, that must be good. If it comes from a tree that goes 1,000 years, that's probably pretty good. There's a couple of components of ginkgo. There's flavonoids and terpenoids. The problem with it is that this has been really well studied. I mean, very well studied, and have never shown a cognitive benefit. It hasn't reduced the risk of Alzheimer's disease. And even in tests of people who have normal aging, it doesn't change their progression or risk of anything. So, you could take ginkgo for other reasons, but to take it to help maintain memory function is probably not one of them that we know of for now. Coconut oil has been talked about. Coconut oil has caprylic acid. That's a medium chain fatty acid. What got people interested in this is that in the brain, these medium chain fatty acids, the brain converts them, or they are converted to ketones. And you may have heard, a ketonetic diet and ketones and stuff like that. In ketones, the brain does work metabolically better with ketones. So you think, oh, maybe that should help. But again, there's no studies to show effectiveness. And even in products that kind of were developed with the same idea, there's been little benefit. So that too, kind of strike out on that. So at least we don't have any evidence that using coconut oil helps you at all. Polyunsaturated fatty acids. And the one I want to specifically talk about is omega-3 fatty acids, or DHA. Now, this is really kind of interesting because these fatty acids really make up the membrane of brain cells. So they have a fundamental role in the brain, in maintaining brain cell structure. So you can get the DHA, or omega-3 fatty acids, from fish. And there's a lot of studies that suggest that that taking a higher intake of like fish in your diet may actually have a cognitive benefit. Now, when they were actually tested in Alzheimer's disease, I mean, specifically Alzheimer's disease, it did not show a benefit. But again, this may be an issue of trying it too late in a process. And it may be that we all should just be incorporating at least some fish once or twice a week into our diet. By the way, in talking with nutritional experts, it does seem that there's not a great advantage of taking the pills, omega-3 fatty acid pills or capsules, versus actually just incorporating fish, salmon or whatever, a couple times, twice a week or 3 times a week, something like that, because it's you actually, can't fool Mother Nature, and usually you get more out of it taking it from a natural source. I also want to briefly talk about marijuana. Not that any of you use it, but so marijuana contains cannabinoids, and actually the brain has receptors for cannabinoids. And again, in a petri dish, stimulating these receptors may protect cells. It may reduce inflammation in the brain. We know it can improve appetite. It can improve agitation. It can improve sleep, at least anecdotally. So I want to put in that caution. But the study results are very inconsistent. There've never been any large studies with these products, and for various reasons, most regulatory. So we really don't know. And all I can tell you is that there's not strong evidence that it helps cognitive function. And if anything, there's evidence that, or there's some evidence that it actually make things worse. Certainly with THC. But I think the big thing about using any of these products, we don't know the dose. Again, same thing. We don't know what the appropriate dose is. As you know, you really don't know what you're getting, because there's no supervision of that or regulation of that. And it just comes down to, we need more studies, and hopefully that will happen. So again, I don't want to diss cannabinoids and people using it and stuff like that, but there's not any evidence yet that it somehow protects the brain or things like that. It probably does have some symptomatic effects for sure, but I think that's about all we can say. All right, I want to move on finally to another topic, kind of finish up things along these lines, which is really this kind of difference between normal forgetfulness that we might have talked about with processing speed and stuff like that, versus the start of Alzheimer's disease. Alzheimer's disease is, again, a very common thing to happen with aging. If you get past the age of 85, probably at least a third to a half of the population have it. And if you get into 90, probably over half of the people, or close to that, have Alzheimer's disease. So it's a very common thing to happen. Now, one of the big kind of breakthroughs, I guess, in some sense, that have occurred over the last 10 or 20 years, well, maybe 10 years, is just this recognition that the disease process is very long, and starts actually in the brain where you have no symptoms. So the disease begins, you start seeing this accumulation of a protein called amyloid, and that starts before you even have symptoms. Then people eventually start having symptoms, and they're usually very mild. There are things like, forgetting where you put your keys, or parking in the garage and not remembering where it is. Now, keep in mind that I think that happens to most of us anyway, to some degree, but where it becomes more, more frequent, takes less stimulus, or like if you're really trying to remember where you parked your car and you still can't. So, and then from those kind of milder changes, then at the end of the whole disease process, that's when you develop what we call dementia. And what we think is happening in the brain is that first we get this deposits of the protein, amyloid protein, that this makes up the plaques in the brain. And then this protein may cause inflammation to occur. That's what this microglial activation, that's kind of inflammation. And then it triggers another protein, which is called tau, T-A-U, and that forms what are called tangles in the brain. And then these tangles start to spread, and then you start getting all the damage to the cells themselves. And that results in dementia. So again, this is a very long process that occurs in the brain. So we're talking about not just this type of thing, but this kind of increasing, so the red line showing this kind of increasing accumulation of pathology over time, which is not normal. And as this pathology increases, then people who have the disease, you start seeing them actually decline, but really much more noticeable than somebody who's normal. So sometimes we're often asked, well, what's the difference between dementia and Alzheimer's disease? And dementia is just defined as a decline in memory and other abilities, other cognitive functions, that has reached a point where it impairs your social or occupational function, and where you're not delirious. Delirium meaning that you have some acute illness or something like that. So it's really just an adjective. It's a term of severity. So, because many things can get you to dementia. Alzheimer's disease can, although we know it's late in the disease that occurs, but you could have dementia due to strokes. You can become demented due to brain tumors. You can become demented due to vitamin deficiency. So there's a lot of things that can cause decline in memory that impairs your function. But it is true that Alzheimer's is one of the causes that can do it. Now, can we then predict who is going to develop Alzheimer's disease? And the answer to that question is yes. So we have the technology now to predict, within at least 10 years if you're going to develop Alzheimer's disease. And there's several ways we can do it. They're all based on measuring that protein called amyloid. So we can measure it in two ways at the moment. One is through measured in the spinal fluid, and the other is by imaging it with what's called PET amyloid imaging. Now, what I'm showing you here, it's a little complicated, but this is a spinal fluid test. So if we start at time 0, the bottom line is time up to 5 years. So this is a time in months. So at time 0, if you get your spinal fluid tested, there's 2 pathways you can go. So if your spinal fluid is normal, doesn't have amyloid in it, or the amyloid's normal, which is the gray line, you could see the chance of actually developing Alzheimer's disease is very small over the next 5 years. So this, by the way, the vertical line is the number of people progressing to Alzheimer's disease. So basically you're pretty safe for a while. If it's abnormal at the starting point, then over time, as time goes on, the chance of developing Alzheimer's disease gets more and more, meaning that it's going in this graph, it's going lower and lower, which means that the chance of developing Alzheimer's disease is higher and higher. So that by 5 years, almost 80% of people who have abnormal spinal fluid at the start will have developed Alzheimer's disease dementia. So we can predict, and by the way, this is turned out to be critical for our research now, because the thought is maybe if you remove amyloid early, before you have any symptoms, you can actually prevent, or probably not prevent, but certainly delay the disease progression. And this is just a kind of a visual of the same thing of how we measure amyloid. So this is called PET amyloid imaging. The top row is PET scans from a normal person. And the way this is displayed on this bar is that the warmer the color, the more amyloid there is. Now we discount this stuff that's in the middle, because that's just not specific. It's just unspecific binding, so doesn't mean anything. So really, if amyloid's in the brain, it will be on the perimeter of the brain. And you can see here, the perimeter is either green or blue. You don't really see it. On the bottom, we see somebody with Alzheimer's disease. And you can see it's full of the red, even out almost to the edge. You can see it all kind of all around. So through this imaging, we can, again, or the spinal fluid test, we can detect if you're at risk of developing Alzheimer's disease within the next 5, 7, 8 years. What are the risk factors for Alzheimer's disease? Age, of course, is one, probably the biggest. It is, the older you get, the more likely you're going to get it. Your genetics is the other big risk factor. So if you have a family member with the disease, first degree family member, that's a parent, brother, sister, you're at increased risk. And we know certain genetic risk factors that we can actually measure. One's called ApoE4. Cardiovascular factors become risk factors for Alzheimer's disease, longstanding hypertension, for example, and heart disease, maybe diabetes. But again, there are these protective factors. That's what I really want to emphasize, which is the exercise, just with normal aging, higher levels of education, which is why you should be attending these presentations all the time if you can, staying socially engaged. And that doesn't mean you have to socialize with everybody, but just being engaged. I mean, being engaged with the world, getting out, doing things. And then, as we talked about, the Mediterranean type diet. So, got a few minutes here. I'm going to stop and just summarize, kind of covering a lot of ground here. So, cognitive function can remain at a high level throughout life. I mean, that's the bottom line, although we have to work at it. The brain can remodel itself throughout life. And there may be many things that can promote this neuroplasticity. Though it's difficult to measure this in humans. We think that, again, lifestyle probably is the biggest thing. Maybe some of these supplements and kind of pharmacologic interventions may be helpful. We don't have a lot of evidence for them at the moment, but I think if you had to put your money on anything, it really would be the physical exercise, diet, and just this kind of cognitive engagement, along with stress reduction and proper sleep. So there you have it. So it looks like we have, maybe another 8 or 10 minutes. I don't know. Should we take questions? How would you like to handle that?
Yeah, we can take some questions. We've got some questions here in the chat.
You want to just fire them away at me?
Yeah, sure. So first one says, I think you said Benadryl can disturb sleep. It seems to be prescribed to assist sleep.
Yeah, so Benadryl, what I meant to say, if I didn't say it, is Benadryl can be detrimental to cognitive function. So it can disturb cognitive function. Yeah, you're right. A lot of people will say take it for sleep. It does help you, it's just drowsiness. It's just going to make you drowsy. I don't know if it really helps the quality of your sleep, which is the other issue. And so I think there's a lot more evidence for melatonin, by the way, is first of all, being a safer entity. And again, I would caution to stay away from the true sleep medicines. I mean, the things that are marketed as sleep medicines, like alprazolam, Zolpidem, and some of these other ones that are, supposedly for sleep, because they could make cognitive function worse. Plus, you can get rebound insomnia with them.
Great, thank you. The next one says, what about word finding difficulties? You start talking, you get a word that you knew when you started, but when you get to it, it's gone.
Yes.
Yeah.
Just had the experience that a couple minutes ago. So yeah, this is where there is some gradation, because I think we all experience, you kind of know what you want to say, but the word's on the tip of the tongue, and then it like comes back to you 5 minutes later. I think that slowing of processing speed. However, having said that, word finding difficulty can be a common symptom even in Alzheimer's disease. People just can't pull up words. So I think it's a kind of a matter of degree. And I guess as a, I don't know, maybe a rule of thumb, if it's the case that you can't pull up the word, but then it kind of comes back to you, in a couple minutes, or, you get a prompt and it just pops right back. I think that's okay. I think it's, when it starts becoming habitual and you just cannot think of that word, and the speech becomes very halting, is where it may be an indicator of a problem. I will also say this. So, you get better with your practice. So if you are experiencing that, the staying on the tip of the tongue, things like that, then doing things that are language based might be helpful. So whether it's playing Scrabble or I don't know, Wordle, or, doing things that are language based, might be able to help that.
Great, thank you. Next one says, do all people with amyloid go on to develop AD? I thought there were people who had much amyloid but did not develop AD. Yes,
so that's absolutely true. So if you take but I think there's some context to this. So if you take a group of people over the age of 80 and you just measure their amyloid at normal people, about a third of them will have amyloid, but seem normal. They test out normal. Now, whether, again, you follow them for 10 years and then eventually when they're 90, they start having problems, we don't know, because we just don't have studies that go out that far. And there's also clearly people who have a lot of amyloid that look like Alzheimer's disease in the brain that just probably have a lot of reserve that they can compensate for it. I would say this: if you're 70 or 65 and you have amyloid in the brain, that's probably not normal. So it's absolutely true. You can find amyloid in people who are normal over the age of 80, and it's about a third. But whether because they have great reserve or whether they eventually would develop it if they live long enough really isn't known.
Great. Next question, can we get amyloid imaging or blood tests?
Yeah, so amyloid imaging is available, and we have it at UW. The problem with it at the moment is that Medicare doesn't reimburse for it. It's extremely expensive. The other method is really the spinal fluid, evaluating the spinal fluid that is covered by insurance, by Medicare. Now, it does take a procedure to get the spinal fluid. It's a lumbar puncture. It's really not a big deal, but it, it's different than drawing blood. And then eventually we are going to have blood tests. So there already are tests for amyloid, blood tests that are available to measure amyloid and this other protein tau. They're not really used now. One's commercially available, but they're not reimbursed yet because we still don't know their accuracy. I mean, how precise they are. So they may turn out to be a screening tool at some point, but they're just not available now. I mean, they're just not being used.
Okay. Next question is, do you have any info on the drug recently approved by the FDA to prevent AD?
Yeah, so that's aducanumab. This is a very controversial medication. It is approved, so it does remove the amyloid protein from the brain, and it does that. There's no controversy over that. The controversy is how effective that is clinically. That is, does removing amyloid really help you? Because the drug has side effects. It does clearly have side effects. And by the way, it's not really to prevent Alzheimer's disease. It is to slow the trajectory. So people, even with this drug, will get worse. It's just that the hope is it will slow it down. So you can avoid getting dementia. It just keeps you going longer. Right at the moment, it's kind of not an issue because Medicare isn't reimbursing for it at the moment. They will make their final decision in April. So we'll find out in April if they're really even going to cover the drug or how they're going to cover it. I think the excitement for some of us, not everybody in our field is excited, but I think the excitement for some of us, including myself, is that this really is the first drug that has impacts the actual progression of the disease. And there's going to be a whole series of drugs similar to it that eventually are going to hit the market. But it's had a tough go of it to actually be used clinically.
Right. All right, so we do have a couple more questions, but we are right at our time. So I will email those questions to you and we can get them out to the group.
Perfect.
Yeah, so I want to
Great.
thank you so much for joining us today. That was really, really interesting information. I appreciate your time. And for those of you joining us, we're going to be emailing out a video recording of this presentation to everyone that joined us today. So if there's anything you missed or if you want to listen to it again, you'll be getting that through your email that you provided to us to get this link. So yeah, I really appreciate everyone's time. Again, my name is Julie at Ida Culverhouse Broadview, and if you have any questions for myself or for my team over at the Gardens at Town Square in Bellevue, you can give us a call at 206-470-8036. So thank you again, Dr. Bernick. It was a pleasure, and thank you all for joining
Appreciate it.
us.
Thanks a lot. Bye-bye.
Bye-bye.